Did you remember that part on the notes? Push
Yeah.
the insert tab and then find the pie chart. The pie chart wasn't under insert. I looked at both inserts. There was no pie chart under any insert. Actually, I found 3 inserts, and none of them had a pie chart underneath it. You had to go to charts and go to pie chart. And it worked with the example that they gave us. But it didn't work with the homework question that they gave us. So I did actually, what I did was I went through and, the juniors and the seniors and the freshmen and the sophomores, I counted them.
Oh, okay.
Yeah, and so then, so there were, well, I did it just for juniors. I haven't done it for all of them. So for juniors, it was 59 out of 183, which gave me about 32%. And if you look at the pie chart, it's about 32%. So I figured, okay, that's what they're doing.
Yeah. Okay.
Yeah. But yeah, no, it wouldn't work for my pie chart either. So, I don't know. I mean, I think if we have one on the test like that we can still figure it out,
Yeah.
It's going to be lengthy. Okay, I'm going to just check this right now. Aha, I got it. Okay, thank you, Annie.
Of course.
So 0.07 subtract 0.07, got it. Okay. All right, well, should we go over part 2? So we're starting to do that. So yeah, I don't know. I mean, and maybe Drew or Bernice, did you guys get it to work in Excel to make the pie chart and the bar graph?
No, not really.
For the lesson, like you say, yes, but when I did the homework, it didn't. But on mine, it does show insert and then pie chart.
Oh, really? You could do insert and it did a pie chart?
Yeah, maybe. But I was able to do it for the lesson, when they do the samples on the lesson.
But it was under insert for you?
Yeah.
Oh, that's interesting. I don't know. Maybe I have an outdated Excel, or maybe mine's updated. I have no idea. Okay, so that's good. Yeah, mine just had to go to charts and do it, but yeah. Okay, so yeah, so we couldn't get it for the part 2, but you can do it by hand for the part 2. I mean, do we have any questions about how we put together a pie chart? I'm sure you guys have probably all done that.
Yeah.
And the bar graph.
Yeah.
We're okay with all that. Okay.
Yeah.
All right. So then, let's go to number 9, and we got A. Let's make sure everybody's on the same page with that. 7% is the true unknown percent of the population. Do not have traditional phones and instead rely on cell phones. 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8% in the survey, use only cell phones? So what is the mean and standard deviation? Well, the mean they give us is 7%.
Mm-hmm.
The standard deviation, then we would take the square root of 0.07 times 1 minus 0.07 all over the sample size 750. You should get 0.0093.
Yeah.
Okay, so everybody's okay there. Okay, so then B, state the problem in terms of the variable p hat. Okay, so we're looking at whether or not p hat is greater than 8%.
Mm-hmm. Yeah.
Mm-hmm.
All right, so we're okay there with B. Okay. Draw a picture of the normal curve and shade the desired area. All right, so what have you guys got for that? I have not done this yet. I guess I think all of us are in that boat, right? We're supposed to do it together.
Yeah. I don't know. I didn't draw the picture.
Okay. Well, let's do that though. Think about what that would be. Because the mean is 0.07. That's going to be in the middle of our bell curve, right?
Mm-hmm.
Okay. So then, and our standard deviation is about, what do we say, 0.0093?
Yes.
0.0093.
Yes.
So, okay. Close to, okay. So it's going to be just over 1 standard deviation away, right? Would you guys agree with that?
Mhm.
Yeah.
Okay. So would it look something like? You guys can see that. Something like that.
Yeah.
That. Yeah.
Let me see.
Yeah. Does that everybody agree with something like that? No, Annie. Speak now or forever hold your peace.
Sorry, I didn't see what you held up. I was.
Okay. So a normal bell-shaped curve, 0.07 is our mean.
Mhm.
Okay. And then we know that 0.0093 is standard deviation, so I kind of marked 1 standard deviation away
Okay.
from 0.07 and said, well, 0.08 is going to be a little bit more than that.
Yeah.
Okay. And then shade it to the right. Okay. Convert, standardize the values of p hat using the standard normal variable z to find the z-score. Okay. So z is going to equal the value 0.08, take away 0.07, right?
Yeah.
All over the standard deviation. 93. Okay. Everybody okay with how to calculate that z-score?
Pretty much
You got 1.075. Is that correct?
I haven't put it in yet. You're faster than I am.
1.075. Yeah.
1.073.
I got 1.075 too.
Yeah.
Okay, and that's what I got. But then
The
on
answer.
like the answer key, they put 1.073. Do you think that's just like a typo?
It probably has to do with how far we went out on our standard deviation estimate.
Rounding.
Okay. Yeah.
I mean, that's close enough that I feel pretty okay with that.
Okay.
Rounding process. Yeah.
Okay, so then let's look at the area under that curve then.
Using the backflip.
Okay, I have 0.1412.
Yep.
Okay. And is that close to what they had? Yeah, I mean, it's
1.16.
pretty close, yeah. If we had to estimate to the around to the nearest 3 decimals, we would be in trouble by 1, but okay, so 14% approximately chance that this survey would yield 60 or more phone users only use cell phones.
Yeah.
Okay. All right, so we ready?
Yes.
All right, let's You guys ready for the exam tomorrow, or whenever you're gonna take it?
Yeah, I kind of wish we could get it done earlier.
I know. I tried to take it like on Wednesday, and no luck.
It's not even open yet.
Huh? Yeah, I know. I know.
It's not even till like midnight tonight, so we have
I
what,
know.
2 days to take it?
Oh,
Yeah.
it's not open yet, huh?
Mm-mm.
Mm-mm.
Oh.
Okay, that's really a funny question, number 3.
Number 3. Oh yeah.
Look at those answers that you get.
One of these things is not like the others.
Uh-huh.
One of these things just really belongs. That's pretty simple.
So obviously each slice represents a category.
No, don't like pie charts are more visually appealing when the slices are different sizes.
This company is brighter and brighter and has more money than this other company just by what they gave it different colors.
Okay, how are bar charts and Pareto charts related? Okay, Pareto charts are ordered from largest to smallest, going left to right. So
Yeah.
that's the only difference, yeah. Okay, we conclude that p hat is normally distributed if np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. I believe that's accurate.
Yeah.
Okay.
True proportion.
Is p the true proportion or the sample proportion? P is the true proportion, right? P hat is the sample proportion.
Yeah.
Yeah.
What is n? N is the sample size.
Mhm.
If p is equal to 1/4, what is the smallest n that satisfies the requirement?
40.
Seems like it would be 40, right?
Yeah, 40.
Yep, it would be 40.
So I already did kind of the homework, and there's a similar question. I tried working it out, and I thought I had the right answer, but it was totally wrong. Would you just so to find that you do 10 divided by 1/4?
So we're going to say that 40 times 1/4 is greater than or equal to 10. Or in other words, okay, sorry, yes. How would you do that without, knowing the 40? Okay, you would take 10 and divide it by 1/4, yeah, Annie.
Okay.
And
Well,
that's
that's kind of what I did on the homework assignment, and I got the answer, and it told me it was wrong.
okay, well, you've got to check it with the second equation. So it could,
Yeah, well, and I did that. And so maybe I just typed it in wrong and just wasn't doing it correctly.
okay.
So I'm just not sure if I understand.
Okay. Huh, that is weird. Okay, well, we can, I'm just looking at this, though. 40 times 1/4 is going to be greater than or equal to 10, and then 40 times 1 minus 1/4 is going to be 40 times 3/4, which is, again, greater than or equal to 10, so...
Yeah, and it makes sense to me. It makes, perfect sense.
Right.
So,
And
I don't
the,
see...
well, the thing is that 39 would work with the second equation, right? But 39 won't work with the first equation. 39 times 1/4 is going to give us a little bit less than 10. So I do think that is the smallest population that would work.
Okay.
But look at that homework question. If you want, I can open up the homework at the end and we can look at it together.
Okay. We can do that after and just
Okay.
kind of see.
Use the following information to answer questions 8 and 9. Suppose n equals 24 and p equals 0.4. What is p hat?
0.4, right?
Uh,
Yeah.
Yes.
Example's just like the parent, right? Yeah. Then deviation. Point 1.
Yeah.
You guys are just like super fast.
I know.
On one of their shows, honey. Okay, so you said 0.1 is what you got?
Yeah.
Uh-huh.
That's what I got too.
Okay, and then number 10 is 0.3.
135, isn't it? Oh, p hat. Okay.
Is that right? Do you guys,
Wasn't there?
am I getting that wrong?
No, I think it's 0.3 as well. It's interesting how P and P hat. I mean, Brittany's batting average is the exact same.
Isn't there like an equation to find p hat for something?
Yeah, it's x over
Over n.
n. Yeah, that's true. So technically, you could say it's 0.35. Okay, let's see. We want to determine the probability she will get more than 35 hits. Okay. Oh, okay. I'm not sure on this one, you guys. I do think the standard deviation is still going to be 0.3 times 0.7 over 100, take the square root.
Yeah,
See
for
if we can
that
agree on that.
0.046.
0.046.
Okay, I got that for 11, but we're thinking 10 something different.
Wait, what did you guys get for standard deviation?
0.046.
Oh, yeah, that's what I got. Okay, well, okay. So, Annie, to me it's kind of confusing because it does say p hat is x over n. But it says Brittany's batting average is 0.3, and she is the sample that we're looking at. So I would say it's 0.3, but then okay, there are a couple things that I think are funny here. Round to 2 decimal places. It doesn't usually do that unless
No, it's normally 3.
decimal places, right? And so then he almost makes me think it's 0.35, but at the same point last time in 8 and 9, p hat was 0.4. So
I think it's got to be 0.3's p hat.
I think it's
I don't know.
You know what? Okay, let's go with the z-score. We can calculate the z-score and we can calculate the...
So for number 10, it shouldn't. It is a 0.300 over 100. Is that what the equation is?
No, they're already giving us her average, Bernice. So that 0.0300, that is her average. It's not. We don't need to divide it by 100. Okay, guys, I'm going to say it's 0.35, and here's why. When we go to the z-score, if we try and say it's 0.3, subtract 0.3, we're going to get 0.
Yeah, that's true.
So
That, you can't do that.
we have to have something different.
Okay, we'll do 0.35.
Okay, sorry.
So z-score 1.087.
Loading.
1.087, yeah.
Yeah. Okay. Yeah, you guys go ahead and work ahead. I'm going to just make sure I get that too. Where'd you get 1.087?
Boy.
Yeah.
Okay. All right, so we're going to put that into normal probability. This a right-tailed? Yes?
Yeah.
That what we're wanting here? Right-tailed? Are we? Okay. Let's determine whether she'll get more than 35 cents. Yeah, right-tailed. Okay, so I got 0.1385.
Yep.
Okay.
Mhm.
385. Did you get that too, Drew?
Oh, yeah.
Okay, so we got 1.087 for the z-score. We're going to go with 0.139.
9.
Mhm.
Okay, 0.139 for the probability. The true proportion of people who support a political candidate is P equals 0.52, and N. Wait, Okay, you get 0.011. Okay. 1. Okay. Okay, z-score would we use?
Are you doing 0.5 minus 0.52 for the z-score?
That's what I did.
Okay.
Okay. You get 0.0345.
For which number?
Z-score?
The probability.
For number 17?
Oh, what? Okay, sorry. What z-score would we use? I got negative 1.818.
Yeah.
818.
And then I got that for my probability as well, the 345 that you said.
Okay. I guess we didn't. Do we have to do that? We do. What is for the survey results? Okay, so that would be 0.035.
And number 16 is less than or equal to the small z, right?
Yeah. What probability do you compute using normal? But we are looking at a left-tailed. But I've never seen it written that way. But yeah, I guess that's how.
Yeah, I think it's strange.
Yeah, I mean, has he introduced that? I don't remember seeing that. Or has they introduced? Sorry, it's not him. It's not his book. But has that been introduced? I don't remember seeing that.
Yeah, I don't either.
Anybody seen that before?
Yeah, I don't know.
Okay. All right, so 1 through 4, I'm 100% confident we're right on. Let's see. Number 5. That's P is P, the true proportion of this, or the sample is the true proportion. Yes.
Yeah.
So I feel really good about 1 through 6. Annie's scaring me about 7, but I think that's right. I just can't imagine it would be anything else.
Well, and the way we figured it out is the only way that makes sense to me.
Yeah.
I was confused that I got it wrong.
Yeah. Okay. Useful information to answer questions 8 and 9. What is the mean of P hat? We said 0.4. Yeah, because the mean of P hat is going to be the same as the population mean.
Mm-hmm.
Well, it should be. I mean, honestly, you guys, in this case, we could argue that he didn't make the sample, or that the sample size wasn't large enough. It's only 24. And if we multiply 24 times 0.4, we don't get a number greater than or equal to 10. So you could argue that the information is insufficient to tell us, right? I mean, but what else could he be looking for there? What else could they be looking for? But 0.4 times 24 is not 10. 9.6.
I think that is odd. I think we supposed to assume it, even though you could definitely argue that
Yeah.
point.
Okay, well I'm going to make a little note. Okay, but if we assume that that is the case, then the standard deviation would be 0.1, right?
Mhm.
Okay. All right, on number 10, we're going with p hat is 0.35.
Yeah.
Number 11, 0.06046.
Mhm.
Okay, 12, 1.087. Everybody okay with that?
Yes.
Number 13, 0.139.
Mhm.
14, 0.011.
Yeah.
15, negative 1.818.
Mhm.
16, the second one, P, probability that big Z is less than or equal to little z,
Mhm.
we think. And then 17, 0.035.
Yes.
All right.
Or is it 3.6?
Okay. Anybody, should we submit it all at once, or you guys want to do one at a time?
I submitted it. It's 100%.
Yay! You're like always the bravest one. Okay. Well, that's good. Annie, do you want to look at that homework together for a minute?
Yeah, just real quick. It's just one problem that it does that.
Okay. Let's look at it. Which question is it?
Number 4.
Okay. All right, number 4. P equals 4/5. The smallest value of n that satisfies. Okay. P equals 4/5, and we need n times 4/5 to be greater than or equal to 10. So, okay, so here's the thing with this one. If you look at that 1 minus P, that's going to be 1/5. So we need to really look at n times 1/5 being greater than or equal to 10. That's going to be 50. N's got to be greater than or equal to 50. Is that what you got?
No, I got something completely different because the way I did it was based on that first equation. I did 4 divided by 5 is 0.8, and so 10 divided by 0.8 is 12.5.
Okay, so you have to look at both the stipulations. In this case, Annie, that second equation is going to require a number that's larger than the 12.5. So I see what you're saying, and you absolutely can do that, but you've got to check with both equations. In this case, the 1/5 times n is going to require a larger number than the 4/5 times n. Does that make sense?
Yeah, and now that I look at it, I put in 0.8. Instead of doing 1 minus 0.8, I did just 0.8 in the second one, which is basically the same. Okay, I see where I kind of went wrong there.
Okay.
Okay, that makes sense.
All right.
Okay, awesome.
All right. Thanks, you guys.
Thank you. Good luck on the exam.
You guys too. I'm sure you'll do great. I'm glad to get it. I'm excited to get it over with, honestly.
Yeah.
All right. Well, we'll see you guys on Tuesday.
Bye-bye.
Bye.
Okay. Take care.